So this is a question on RC circuit from Jee Adv 2019. So there are two switches in this circuit, S1 and S2, and initially both the switches are kept open. The charges on every capacitor initially is zero, and the values of capacitance are given to you in the question. Now, for the options, let us go through the options B, C, and D first. In option B, it is said that if the switch S1 is kept closed for a long time, then what will be the potential difference across C1 capacitance? So in this option, the switch S2 is open, right? And in option C, it is said that just after S1 is closed, right? Initially, both the switches were open. And just after when you close the switch S1 at t equal to 0, what will be the instantaneous current in the loop formed? In D part, again, it is said that if S1 is kept closed for a long time, what will be the potential difference across these points P and Q? Then in option A, it is said that if the switch S1 was closed for a long time and the circuit was in steady state, then at t equal to 0, you close the switch S2, right? So S1 was already closed and the circuit was in steady state. Then at t equal to 0, you close the switch S2. So just after closing the switch S2, what will be the instantaneous current through this 30 ohm resistor? Okay, so first we'll solve the options B, C, and D, and then we'll go to option A. Okay, so let us start this question. So I've drawn the circuit with only S1 closed. Since S2 is open, so I've not shown that part of the circuit. So S1 is closed and S2 is open. Now, just after we close the switch S1 at t equal to 0, what happens at t equal to 0? Capacitors were initially uncharged, right? And the property of a capacitor is that it does not allow sudden change in voltage across it. So capacitors were initially uncharged, so potential difference across them was zero. So just at the instant when you close the switch S1, capacitors will not allow the potential difference to suddenly change across them. So the capacitors will behave like a short circuit, right? They will offer zero potential difference. This is the property of the capacitor. They will not allow sudden change in voltage. So since the capacitors are acting like short circuit at t equal to 0 just after closing the switch S1, so what will be the equivalent circuit? What circuit will you see over here? Simply there will be a 5-volt battery. All these capacitors will be shorted. There will be three resistance 70, 100 and 30 in series. So the current in this circuit will be 5 divided by these resistances, summation of these resistances 70 plus 100 plus 30. So the current in this loop will be 25 milliampere at the instant when you close the switch, right? Now, when the switch S1 is closed for a very long time and the circuit has reached its steady state condition, means the capacitors are fully charged. So when the capacitors are fully charged, so the current in the loop becomes zero. Since the capacitors have become fully charged, the charge across them is not changing. So the current in this circuit will become zero. The capacitors will start acting like open circuit, right? So you can treat these capacitors as open circuit. So there will be no current in this loop. So what will be the charges on each and every capacitor? So you can see all these capacitances will be in series. Initial charge on the capacitors was zero. And at steady state, we can find the charges by saying that all these capacitors are in series. So what will be the equivalent capacitance? That will be 8 microfarad. You can use this expression for C equivalent since the capacitors are in series. So C equivalent will be 8 microfarad. And the battery potential is 5. So the charge on every capacitor is going to be 40 microcoulomb. So according to the battery potential, you can see the polarity of the battery. So according to this polarity, we can finally say what will be the polarity of charges on each and every capacitor. So we know the charge on every capacitor to be 40. Now, if the charge is known and the capacitance is known, we can also find the potential difference across them. Like for C1 capacitance, the charge is 40 and the capacitance is 10. So the potential difference is going to be 4 volt, right? And since the current at steady state is zero, there is no current in this loop at steady state. So at steady state, the potential difference across this point P and Q will also be equal to 4 volt because current is zero. So there will be no potential drop across this 70 ohm resistor. Current will be zero at steady state. So across points P and Q, the potential difference is simply the potential difference across C1, which is 4 volt. right? So this was the part B, C, and D option which was given to us. So for option B, it was asked that what is the potential difference across C1 capacitance at steady state, that is 4 volt. In option C, it was asked that just after closing the switch S1, what will be the current in the loop, that will be 25 milliampere. And in option D, it was asked what is the potential difference across points P and Q at steady state. So the in option it was given to be 10 volt, but the correct answer will be 4 volt. So option D is not correct. Now let us look at option A. In option A, the switch S1 was kept closed for a long time, and then you close the switch S2 at t equal to 0. Now, when the switch S2 was closed, just before the switch S2 was closed, the potential difference across the capacitors we just calculated, across C1 it was 4 volt, across C4 it was half volt, and across C3 also it was half volt. Now again, the property of capacitor is that it will not allow instantaneous change in voltage across it. So just after when you close the switch S2, this capacitance, the voltage that this capacitance is hold will be half volt for C3, half volt for C4, and 4 volt for C1. These capacitances will offer this potential difference in the circuit, right? So suppose just after closing the switch, the instantaneous current through this C2 capacitor is I2, and through this branch RS, through this branch, the current is I1, and the addition of I1 and I2 flows through this capacitance branch C3, right? Now again, I'm saying that remember that these capacitances, the potential difference across the capacitances will remain as was calculated before just after closing the switch S2, right? So if I apply the KVL in this outer loop, okay, I'm applying KVL in this outer loop. So I'm starting from point R. So you can see that across 70 ohm resistor, there will be a drop since the current I1 is in upward direction. So this will be plus, here it will be minus. So by KVL, it will be minus of 70 into I1. Then across C1, there will be an increase in potential of 4 volts. So minus 70 I1 plus 4 volt. Then across C4, there will be an increase in half volt. Then across the battery, there will be a drop of 5 volt. Then for this 30 ohm, there will be a drop of 30 multiplied by current, which is I1 plus I2. Then as we move across C3, there will be again an increase of half volt. And again, through this 100 ohm, there will be a drop of 100 multiplied by the current I1 plus I2. So if you manipulate this equation, you will get a final equation of 20 I1 plus 13 I2 equal to 0. Next, we are applying KVL in this loop RSPQ. You can see this loop over here. So we are applying KVL in this loop. Now remember that before closing the switch S2, just when we close the switch S2, there was no charge on this capacitor C2, right? So just after closing the switch S2, capacitor C2 is not going to offer any potential difference because the charge on C2 is 0. So potential difference across C2 is also 0. So when you're writing KVL, the potential drop across C2 is going to be 0 just after closing the switch. So let us see this KVL. So there is a drop. We are going in from starting from R and going in the anti-clockwise, sorry, going in the clockwise sense. So first there will be a drop of 70 multiplied by I1. This will be the drop across this resistor. Then we gain a potential of 4 volt across C1, so plus 4. Then C2 does not offer any resistance to me. Then 30 ohm, there will be an increase in potential of 30 multiplied by I2. So since the current is I2 is going upward, so this is going to be plus, this is going to be minus. So when we come down from P to Q, we are gaining a potential of 30 into I2. Then across this 10 volt battery, we lose a potential of 10 volt. There is a drop of potential of 10 volt. And finally, that is equal to 0. So this equation gives me 70 I1 equal to 30 I2 minus 6. So these two just simple simultaneous equations you can solve and you'll get the value of I2 as 12 by 15, which is approximately 0.08 ampere. So this was the option A, which was asked that just after closing the switch S2, here was the switch S2, just after closing the switch S2 at t equal to 0, what will be the current in this 30 ohm resistor? So the current is I2, which is 0.08 ampere.